hello and welcome to this, our second session today, Optical Networks for the Post-COVID Era. And we'll start this session with our first keynote speaker, Kimmo Penttinen, who is Vice President, Business Development Production at Elisa Corporation in Finland. Next up will be Claudio Lugari, who is Transport Network Solutions Director at Huawei. And then we'll finish the keynotes with a presentation from Ian Redpath, Practice Leader at Omdia. Following these three presentations, there will be a panel discussion with Claudio and Ian, and we will conclude this session with an audience Q&A, so please send in any questions you have for our panelists. And you can do this at any time using the Q&A widget at the bottom of your window. Now, I'm very pleased to welcome Kimmo Penttinen, who is Vice President, Business Development Production at Elisa Corporation. Kimmo.
Thank you, Simon. I'm really pleased to have you here. So during my keynote, I'm going to illustrate what are the real customer needs, especially now during the pandemic COVID-19. What are the expectations to have high-speed, high-quality connectivity, independent of whether it will be a fixed or mobile connectivity. And here as a use case, I'm illustrating what we've been doing and what kind of experiences we have had with the customer here in Elisa Corporation in Finland. As you all know, telecommunication service providers are living difficult times. Already before the COVID, the average revenues been going down 1% each year, and that's the reason for change. And it seems we have been lucky in many times here in Elisa Corporation for providing connectivity services, because although we've been in business pretty long time, 137 years, in the last 5 years ago, we have always each year made best results ever in terms of revenues and profitability. Also been actually running up digital service being now about 15% of the revenues. So it has been a good years, and now of course the question is that how to cope with the similar kind of track record during the pandemic and COVID. And it has been actually awesome in the last month. Actually, it's even more important than ever to have a reliable connectivity, because as we have today, people are attending different kind of events online. The video consumption is actually booming. It's increasing significantly day after day, and we have been witnessing actually 40% of higher data usage than a year ago, and the similar time of the period. At the same time, we've been also been able to keep on the profitability and high level of customer satisfaction. I will argue on this presentation that here the key is that one should be always remembering that what's the end user customer experience, what really matters, independent of what is the different kind of connectivities available, because in many times they are using and utilizing different kind of connectivities during their daily work life and life outside work. And also all the time the organization should be able to try out new things, to be adaptable and innovative and find out new ways of working and finding out of improvements. Improvements in customer satisfaction, improvements in quality, as also in terms of cost reductions. So it all boils down that although the technology matters, what matters most is to have a good insight of the customers and creating services based on that, and if needed, reshaping the business models. And that's where we are aiming at the moment, I would say, globally in the connectivity services, to have ultra high speed everywhere. And here the key drivers are different ways of utilizing especially video communication, as we are witnessing now, massive IoT, but also more and more the new technologies also driving the user adaptation, as for instance 5G services. And introduce you about the markets, the dynamic, what we are actually having here in Finland, because I think there are several interesting impacts to take as an insight. So one is that having a strong balance between fixed broadband and mobile broadband, heavily used in enterprise and also consumer customers. Secondly, high level of digitalization, enabling high level of connectivity and utilizing different kind of video services. And then what I was already mentioning, the outstanding use of the mobile data. So at the moment, average of users here in Finland is using around 11 times more data per user than it's used in Germany. 6 times more than in UK and 3 times more than in the United States. It's the highest usage of mobile data than any kind of other country in the world. And in many aspects, it's already on the level what is predicted to be in future coming years in the area of 5G. And also at the same time, we've been highly profitable, as I said. So how you can maintain high quality services at the same time being capable of managing high data consumption. There's only one way to manage it, and the way to manage it is a high level of automation. And I think this is one key figure here to illustrate it. So year after year, we've been increasing the level of utilizing machine learning for predicting the incidents before they happen. And nowadays, actually, 93% of faults can be identified even before they happen, even before it has any kind of customer impact. And the result is that there is 70% less customer impacted incidents, keeping in mind at the same time the utilization and the volumes of data being increasing significantly on the same time of the period. And here is another perspective, the same topic of automation. You can see on the right side that we've been able to keep flat our investments and also operating expenses in last 8 to 10 years, while at the same time the data consumption being highly expanding. And you can see on the left side, step by step, utilizing different ways for automating different level of technology infrastructure, network communication infrastructure. One of the here interesting insight is that actually each day we are going to 4 million different configurations and in mobile networks, in base stations, and making a high tuning to be optimized, that it will be actually based on the best engineer knowledge. But there are no engineers left anymore in that loop. So it's all based on the machine learning, and around 30,000 different changes are made automatically. And in that way, we are actually significantly reducing the amount of hardware needed to run the operations and running the data flow in our network. And here is another aspect. So if one aspect is high level of automation, another one is to try out and take out of the box. What are the business models? Which are actually the business models which are best fulfilling the customer needs. So after all, customer is not interested whether it is 4G, 5G, Wi-Fi, fixed broadband, fiber connection, or what the customer is interested, whether it is enterprise customer or consumer customer, that it works. And in that way, in mobile broadband nowadays, we are actually providing all you can need business model. So as much as you can utilize, no data gaps, and all is based on different speed tiers. And as you can see here in the middle, the result is increased revenue, and achieve. Now I'm not going to go through all in details, different kind of services we've been now launching in last 1 year here in Finland, but a few highlights just to give an insight and understanding that there is even more usage of high-capacity data, high-quality data. For instance, we've been demonstrating that it's totally fine and possible to provide 12K resolution video broadcasting from the commercial 5G network. In a similar way, we've been also demonstrating and launching first in the world remote control of tractor, where actually it's all based that you have a 360 view on real time from the tractor to the right remote pilot, and it's all based on a high bandwidth and high connectivity. And here the same case with 8K resolution on the air, so you can actually have a different kind of possibilities to utilize the drone flights and 8K high-level 360 live video for doing different kind of inspections. As also now there's actually, we are delivering this kind of 8K solutions for remote education. There's been actually increasing interest now during the pandemic. Again, this is surely quite common knowledge for all of you. So what is the difference between 8K, 4K, Full HD, and actually the resolution what we are witnessing now is just a small slice of Full HD. So I believe it's 720 pixel resolution what we are witnessing. Without forgetting that the cloud, different kind of cloud services are booming. And here's one perfect use case for using cloud rendered 3D models to have the same kind of look and feeling in a 5G phone through Thin Client, that you're actually running the 3D model in your phone, but actually it is running on the cloud, and you can enjoy the model in that way virtually. And here the technology is actually based that you can stream as a dynamic video content to your phone from the cloud. And again, like to emphasize, technology is important, but the customer experience is even more important, and therefore it matters to do fast experimentations, trying out what really matters for the customer, how to create a better quality capacity, better quality connectivity, and with even lower prices through high level of automation. So hopefully this presentation has been giving you an insight how and why customer experience matters, and what will be the key takeaways to innovate to have a better performance in automated high quality connectivity. Thank you all.
Okay, thank you, Kimmo. And for our next presentation, we're going to Claudio Lugari, who is Director of Huawei Transport Network Solutions. So that should be coming up.
Hello everybody, my name is Claudio Lugari. Hello everybody, my name is Claudio Lugari. I am Transport Network Solution Director in Huawei, based in Milan, Italy. Welcome to this all-optical network enabling premium experience in post-COVID era keynote speech. First of all, let me say that this pandemic was a tragedy and so many lives were lost. So our thought and our hope is that this will end the sooner the better. Then, in order to fight this virus, we had to change our habits to the point that our lifestyle has been modified and we are still struggling to get back to our normality. This new reality, done of lockdown in the worst period and then of masks and social distancing, hit not just some country, but the entire world, and the number of people affected is huge. So if before the pandemic we could go freely and attend the crowd events like sports event, soccer, football, basketball, whatever, send children to school in order to go to the office or to go shopping, during the pandemic more than 60% of the global population was forced at home. Meaning that part of it, and let's say more than 300 million people were in smart working, more than 120 million students attended online education, and online shopping was increased 6 times. Some of these trends were already there, but the pandemic made them mainstream applications, and the network risked not to grant the required connectivity under the heavy load of the requirements and the scale of them. So also the scale of this phenomenon is very important. With the awareness that in many cases actual architecture could not cope with the requirements, we know that our live education requires a premium home broadband. During the pandemic, children's education issues drew global attention, and the suspension of classes and non-stop school became a major concern for teachers and parents. Every family is working hard to create the best online learning environment for children, also taking into account that when the school will need to open again, maybe the virus will be still there. So online education could be a durable trend. So the point here is that the home network with zero buffering and zero disconnection is key to ensure the kind of quality needed for children's learning. Bandwidth must be granted in order to have a fruitful real-time interaction. One more trend pushed by the pandemic is the e-commerce. More and more users use e-commerce to meet their daily life's need. We found that e-commerce has also derived new application scenarios, such as live e-commerce. Merchants or live streamers promote products in the form of live broadcasts, and users purchase their favorite products through apps. This new retail economy is rapidly rising, and it also places higher requirements on network connections. For the live streamers, it would be impossible to accept any interrupt or packet loss. To satisfy the needs of users, in this case the latency is pushed to less than 100 milliseconds, so the broadcast platforms and the relevant transport architecture must grant this level of good interaction. But beyond online education and online shopping, which are new applications that could take advantage of reliable private lines through optical technologies, let's consider traditional consumers for these applications. Enterprises, financial and governmental institutions. All enterprises are accelerating to the provisioning of online services, and in doing that, they are also improving their service capabilities for the users by digital transformation. As far as banks are concerned, just one very important example in between many, the high-speed interconnection of various branches and between branches and headquarters data centers has become the key for the bank's digital transformation. The dedicated line interconnection of the bank also requires the highest possible availability of the network, and financial transactions forces latency to the lowest possible level. So the paradigm has become 5 nines of availability and 5 milliseconds of end-to-end latency. After the pandemic, we think that more and more companies will move into the cloud, pushing more stringent requirements on the connectivity through transport network. Considering the background I just described, how should we adapt to the needs of premium services in the post-COVID era? In Huawei, we believe that in order to meet the new stringent requirements of best quality services, we need to simplify the network architecture to make it more flexible and controllable in an automatic way. The best option that we see is an all-optical network architecture. Transmission technologies like OTN and WDM can grant high bandwidth, low latency, service separation according to different service level agreement in order to differentiate them, flexible bandwidth adjustment, and high security via encryption. In the core of the transport network, ultra-fast transmission technologies based on 200 gigabit or 400 gigabit wavelengths enables high-speed interconnection crossing long-haul networks. Metro network can move from 10 gigabit wavelengths to 100 gigabit ones, getting finally rid of dispersion compensation modules to realize full coherent infrastructure, and the same speed can be reached into the access, so I mean 100 gigabit. At the same time, OTN syncs to central office, seamlessly connecting with enterprise access, home access, and 5G access. The entire network features end-to-end next-generation OTN technology, end-to-end optical cross-connect technology, which means platforms with a real optical cross-connect backplane, which is definitely simplifying not just the core but also the regional network, allowing much more connectivity on the pure optical side. And even more important, an end-to-end intelligent management and control system to achieve one-hop direct access in all optical network and build a future-proof infrastructure for the next decade. So to summarize, all optical network architecture can grant very high bandwidth, and here we are talking about single wavelength of 800 gigabit if we think about state-of-the-art, which grants 48 terabit if we also, over the single couple of fiber, if we consider the super C-band, so extending the spectrum from the actual C-band 4 terahertz to the super C-band, which is 6 terahertz. We can grant ultra-low latency thanks to the technology and platform improvement and the fact that the architecture allows much more connectivity. And we can improve the reliability thanks to the fast restoration protocols like ISON at both electric and optical level. And obviously, the network can be digitalized, the resources can be visualized thanks to the SDN implementation, which is done through iMaster Network Cloud Engine. And let me just remind that the vision and mission of Huawei is bring digital to every person, home, and organization for a fully connected, intelligent world, which perfectly fit this speech. And thank you so much for listening.
Okay, well, thank you, Claudio. And our final keynote today is going to be from Ian Redpath at Omdia with an update on the optical network market. So over to you, Ian.
Hi, Simon. Thank you. Is my audio coming through okay?
It is indeed.
Okay, thank you. So again, yes, Ian Redpath, practice leader for components, transport, and routing at Omdia. I'm going to talk about the digital economy and its relationship to the optical core. The digital economy drives the optical core, and then at the same time, the optical layer underpins everything that does happen in the digital economy. So economies worldwide have been turned upside down due to the COVID pandemic. A public health shock has turned into a macroeconomic shock. Countless businesses and workers have shifted to the at-home model, and the relocation of the economy really required a first ever massive shift in bandwidth resources. So at the same time, the digital economy has been growing and continues to grow. So I'm going to focus in a little bit on business cloud services, and then also talk a bit about how 5G applications and business models will really drive this new phenomena that we're seeing around edge compute. And both cloud and 5G apps will continue to catalyze and change the optical core. Another thing that we've been looking at is high capacity wholesale services from a carrier perspective. This is something that we've seen rejuvenated. It had been going on pre-COVID, and got the COVID acceleration bump, and we expect more. So I'm speaking of very high capacity carrier Ethernet services, wave services, and the like. And then another thing that we've been tracking through all this, and it's kind of an unsung thing, but it's what I like to call network effects. And it's really about fiber connectivity and optical connectivity, and extending networks everywhere. And every time you add another node or add another interconnection point, you make your network inherently more valuable. So it's been an interesting transition time, and you know, a lot of the trends that we were seeing before have been accelerated, and we expect to continue post-COVID. So just focusing in on business cloud services. So for a number of years, I've been tracking what I like to think of as a couple of the bellwether providers in this area, both AWS and Microsoft Commercial Cloud. And my little revenue graphic here, you can see that's the revenue performance for those business units specifically within those larger corporations. And over the last 5 years, you can see tremendous growth. The last data point I have is for the calendar of the end of the first half of 2020. So, you know, you can see quite quickly that this market is already a $100 billion market, and this is just two of the leading. There's many other folks that would be contributing to the overall business cloud service revenue line. And you know what we see, the great appeal here to the entire cloud service is what I like to think of as cloud economics. You're getting compute and storage at, you know, massive economies of scale type of pricing. And so many of the collaboration services and the entertainment services that did receive a lot of press through the COVID shock, you know, they utilize cloud service. So, you know, a couple of simple examples. I mean, Teams, of course, rides on the Microsoft platform, and Netflix uses AWS. And so it's an interesting dynamic there. You know, one of the tenets of cloud service is to be able to rapidly scale. And so they were able to take advantage of that through the cloud transition. So cloud continues to have an appeal, and the whole at-home model will continue to leverage cloud. And then there's a couple of other, you know, angles in there as well. You know, everything to do with disaster recovery and remote backup, that will all be heightened, you know, during times of crisis. And then another key thing with cloud services is life cycle costs. So moving to a cloud model allows enterprises to move some of that life cycle cost over to the cloud. So there's a great benefit there for enterprises. And so the reason that, you know, as an optical person, I've been tracking this is because it drives two great industry roadmaps. It continues to drive the data center construction roadmap, and it continues to drive the bandwidth and the connectivity roadmap. So it's really driven what I like to think of as a global hierarchy of end-to-end data center capacity, and then that needs to be connected as well. So I have a little graphic here that gives you a view of the internet content provider community and their objectives when they're looking at bandwidth. So, you know, the digital economy is led by the leading internet content providers. Their bandwidth needs are pretty straightforward. They would like lots and lots of bandwidth at a very low cost per bit. And when they're building their networks, there's a number of pieces to it, and it's basically a kind of a build their own model in the high capacity core, and then go to the carrier market when they get a little bit beyond their core, when they get, you know, when they're going into brand new territories, or they're going more to the network periphery. So, you know, there are cases where they do build out their own fiber, and then they're also involved in larger consortium ownership, where they're a partial owner of fiber. You know, we hear quite a bit about the dark fiber market. They're involved there, and then the high capacity lit service model. So I use the term lit service, and you know what I mean by that. It can be very, very high capacity Ethernet services, OTN services, wave services. All of those, you know, would qualify as lit service. So they've been doing more and more with lit service recently. There has been some very recent press. A number of carriers announced terabit scale deals here with the internet content providers. The press releases usually focus on the terabit levels in aggregate, but what it translates to effectively is often an awful lot of 100 gig E deployed broadly across folks' network footprint. So there's a very clear trend here, more and more high capacity and more 100 gig as a service. And that was growing pre-COVID, and then a COVID bump or acceleration, if you will. And then we expect that to continue on after we hope the pandemic subsides. So, I kind of mentioned 100 gig as a service. What about 400 gig as a service? So we're starting to hear a little bit more about that. We have seen some 400 gig as a service press releases. So we're always stepping up in terms of bandwidth and speeds and feeds, 10, 40, 100, 400. So 400, will obviously be next. So where are we right now in terms of market development for 400 gig as a service? So I expect the early adopters to come from, exactly where we would expect from the folks that were aggressive adopters of 100 gig naturally. And, there's a few types of folks in the industry that would fit into exactly that, the internet content providers. From an enterprise side, the financial community is always the leader here. And then we do expect a little from carrier to carrier in a wholesale capacity. So a number of the ICPs have been quite vocal about their 400 gig strategies. And really for them, it's a total end to end. So, and in their context, they're thinking, right from beginning inside the data centers, the top of rack switches, converting that from a 100 gig era to a 400 gig. So there we're talking about, the datacom distances, the 300 meters, the 500 meters, the 2 kilometers, all the connectivity that goes on inside their fabrics, inside their massive scale data centers. So a transition beginning there to 400 gig. And then some of them have been quite public about, not having an extra muxing stage, muxing up or down. They would like to go from 400 inside the data center to 400 gig right out the door. So that becomes a bandwidth driver for 400 gig in the WAN. And we've been hearing more and more about that. So, we expect this transition to begin and to ramp. And then, back to the financials, the financial community always been at the forefront of advanced technology adoption. They just have all the pieces to drive that. They do always want to stay on the technology forefront. They have the financial wherewithal to do it. And, sometimes early days of technology adoption, you're going to have to pay a little bit of a technology premium early days while the market develops. They have the deep pockets to do that. And then they also have the resources and the technical sophistication to also take advantage of that. So we expect the financial community to continue to lead. And then, as the market continues to develop, we expect things like when carriers are entering new territories and working with other carriers in partnership, wholesale arrangements, if they've got 400 gig in a backbone core and need that a little bit to complete legs, they'll begin to ask for 400 gig there. So, it's beginning. The way I'd characterize it right at the moment is it's still early days. And, we expect to see more of what we've already seen, really kind of as a special service. We expect to see, more marketing announcements. And the market needs to develop and get to that real kind of critical mass. So critical mass in terms of networks being 400 gig capable, and you need to get to endpoints that are 400 gig capable, and the demand needs to come along as well. So we'll move from, specials to ultimately a real robust end-to-end mesh kind of 400 gig, but all in good time. And, coming back around a little bit to the edge compute topic. So first off, what is edge compute and why do we need it? And, fundamentally, everybody needs more compute. So large enterprises, small, medium enterprises, at-home folks, everybody needs more and more compute for all manner of applications. So the historic choice is, I can either pay for more compute and manage the compute, and think not like 12 months, but think 10 years, manage compute at the edge. Or I could look to adopting a cloud model and benefit from the cloud economics. So this has been going on for some time. We had some early renditions of cloud service, and some of the early renditions of cloud service, so I'm speaking really early, were internet-based, and so internet best effort. And some of the cloud resources were deployed, around the country. So depending on where an end user was and where the actual resource was, you could have a longer latency situation. So you could have a combination of internet best effort and subpar latency performance. So obviously kind of a 1.0 situation, and people wanted to move along and get to a 2.0 situation where performance is improved. And so what edge compute attempts to solve for is, you move compute closer and closer to end users. So you get, the lower latency performance. And one of the magic numbers that has been mentioned is 5 milliseconds. And Claudio noted that in his talk. And then also replace the best effort networking with real guaranteed performance networking. So high bandwidth, and then predetermined latency on primary paths and predetermined latency on potential failover paths as well. So the edge compute market is beginning, and we're actually starting to see some interesting CSP and ICP partnerships. So working together, and in terms of these early days edge compute deployments, people are being pragmatic and utilizing assets and resources that are already there. So said a little more directly, we're seeing repurposing of central office assets, taking out historic equipment that is kind of end of life, repurposing, so upgrading for today's standards for power and heat dissipation for high performance compute. And then, those CAO sites, they were always fiber-rich sites to begin with. So, an important thing to keep in mind here is this is going to be a long technology arc. I mean, think, in terms of decades. We're starting today repurposing, but over time, this edge compute capability will get closer and closer and closer to the network edge, and all edges, really. So the residential edge, the enterprise edge, and the mobile edge as well. So what is this going? What's this all going to look like? Now and as we move through the COVID period. Some of the things that we're thinking about, and we've heard some of this discussion already. I mean, folks will absolutely accelerate cloud strategies, but at the same time, they're really looking to reduce cost. And, a simple example of that is, think of a medium-sized enterprise. If the at-home model, truly takes hold, is there a way to reduce cost? Or even if we're in kind of a hybrid environment of at-home, how can we take down cost. So I would expect companies to, they're always going to hold on to their core real estate assets, but you might have some more peripheral properties that are a little high cost, a little underutilized. I would expect, some squeezing there to reduce cost, which will end up, having an impact on the bandwidth market. And, we need to be prepared that such types of things are going to be coming. And another phenomena that I think we're really going to see is, again, as we get into this hybrid work at home environment, it was all well and good to utilize that broadband connection that you had there in hand when you move to the home. But it's really got to take a step up if we're going to do this long term. We really need to professionalize the at-home environment, and it really needs to be treated like a branch office or a small office with diversity and low latency and rapid failover capability. So all this to say is we're due for some more bandwidth change, and what I see this impacting is two major types of bandwidth. What I like to think of as the fan-in bandwidth. So all the bandwidth that's coming in from the edge, and there's multiple types, and there always will be multiple types: MPLS, carrier Ethernet, more and more SD-WAN, and even waves. Obviously, out to the bigger sites, and then hitting an edge compute node, and then it will become much more aggregated bandwidth. And out of that, we'll see waves and high capacity carrier Ethernet, potentially OTN in between the compute nodes and the cloud core. So to kind of distill that aggregated bandwidth down, that's going to be 100 gig-E's and ultimately multi 100 gig-E's. So getting to my concluding slide here, what does this all mean for carriers? We're really in a very, very challenging environment. Obviously the macroeconomics are very, very challenging. We're in turbulent waters. And, from an enterprise vertical point of view, we are seeing, highly successful enterprise verticals, the cloud native, the industries that already had a very, very substantial online presence. There's absolutely success there, but that, at the same time, there's distressed verticals, and distressed verticals will ultimately, it will get to revenue lines and CapEx lines. And I think we're really in for, unknown types of recoveries. We've heard many different types of recoveries, offered up V-shaped and U-shaped and L-shaped and inverted square root shaped. I think the bottom line is, uneven, and it will take some time. The good news is that, everybody does need more bandwidth. That's clear and that's apparent, and that's something that our industry can continue to help with. So from the carrier perspective, there is the digital economy customers to pursue directly. They're a demanding and challenging set of clients, but they do represent a lot of capacity when they come your way. Enterprise is absolutely going to be adopting more cloud, but also re-architecting and looking to save cost where they can. And then, we will see more and more wholesale business as well from a high capacity point of view. Many carriers are continuing to globalize, and we're going to continue investing in 5G. At the same time, well, the carriers need to deal with all that. They also need to deal with, intensifying competition. And we've seen some pretty interesting developments from that part of the market as well. Labels are always tough and fraught to survive, but we are seeing what I'm calling emerging CSPs. So it's smaller, but more wholesale-focused CSPs. And, you know, I would not be dismissive of these kinds of competitors. They may start small, islands, if you will, islands of service territory. But they do have a clear eye on the market they're going after, and they're being well funded. So they're growing. So they're plugged into the ecosystem, and they're growing as well. And then, you know, in response to that, I think we've really seen the tier one wholesale units rejuvenated. A lot more activity and going after, you know, this 100 gig as a service business. It's out there, and they're going after it. So where does this leave us with network effects? I mean, it's a fundamental, but, you know, at the same time, it's more valid than ever before. And folks need to connect their customers and to the key telecommunication assets. And I think, you know, another thing that's kind of been highlighted through all this is the value of diversity and the value of low latency. It's just being more understood within the enterprise community. It's more highly prized, and so, you know, people do want latency guarantees, and, you know, diversity has given way to a new little industry buzzword, triversity. So, you know, not just two, but three where you can. So I think the kind of investment environment that we can expect to see is, you know, folks will spend CapEx through this turbulent period, but with a real clear, you know, line of sight to revenue. When they can see the return, you know, immediately, then they will spend. So that includes my talk. Thank you. Back to you, Simon.
Okay, thank you, Ian. So that brings us to our panel session. This is our second panel session today. And for this panel session, I'm going to be joined by Claudio from Huawei and Ian Redpath from Optia. So what we're going to do for this session is I've actually lined up 5 topic areas related to COVID, but also networking and the impact of COVID on networking, both now and going forward. So we're going to address each of these, being significant network challenges, the biggest changes from the pandemic, optical technology developments, innovations and new practices, optical networks at the edge. And then at the end of this, there will be an audience Q&A. So please send in your questions that you have for our 2 speakers as we go through. Well, with that, I'm going to go on to this first question. And what am I going to do with these? For each of these topic areas, I've got a question, and I'm going to go to each of our 2 speakers in turn for their thoughts on these topics. So the first question, I'm going to go to Claudio first, and that is, what have been the most significant network challenges during the pandemic?
Hi, Simon. Thank you. So let me first greet everybody. Huawei is not a service provider, but a platform and solution provider. And what we have seen as partner of many service providers across the world is that the bandwidth demand skyrocketed, pushed by a total new condition. So my personal experience was that in March I was coming back from a business trip. I was stopped in Italy, and I had to adapt my life to this new condition, which is millions of people forced at home for security reasons. And then millions of people forced at home means that the lucky ones, the ones that could afford a remote connection for job, were forced to work from home. In the case of children and students in general, because it affected from the primary school to the university, we had online education and even online exams. So obviously everyone had entertainment at home. The situation brought a lot of video conferences, remote cooperation via video voice calls, e-learning platform, huge video streaming, and social media usage. It is worth noting that this bandwidth request was not in all the areas, because checking, obviously there was an increase overall, but international roaming, for example, was strongly reduced. And as far as I know, it was exactly due to the fact that international movement and particularly tourism was blocked. So it was, for example, affecting a lot Italy. So anyway, we can say that bandwidth demand overall skyrocketed. And then if you check, the broadband traffic grew up to 80%, depending on the geographical areas, because this was another factor. Many people moved from cities to rural areas, like in my case, and in those areas the demand grew up even beyond 100%. I remember very well after 1 month people leaving Milan, for example, for the south of Italy to reach their original homes, or Paris, leaving Paris to go to Bretagne and Normandy, and the same, I think, happened in New York. So, pushed by these sudden changes, some, if not all operators have been forced to rapidly upgrade their part of their networks in order to face the burst in bandwidth demand. And to do that, they had to keep their operational teams fully active to drive their overloaded networks. At the point that, again, in our experience, we had meetings canceled because our customers were dealing with continuous emergency situations. And beyond that, the burst in demand also affected the quality of the services provided. The most notorious example is that Netflix, YouTube, and Akamai were asked by the governments to reduce the video streaming quality from high definition to standard definition. And here we are not talking about the super fancy levels of 4K, 8K, so it was moving from high definition to standard definition because the huge video streaming was overloading the overall network infrastructure. This was badly affecting not just video streaming, but the services in general, with the risk of an entire network failure, which is quite a good example of network contention. And the same could be applied to families. Many families were and still are very anxious about the quality of the home broadband network. And in particular, during online lessons, parents were shutting down all other internet applications to ensure their children's stable experience. The same applies to smart working, and I was often forced to ask my family to stop video streaming in order to attend even evening conferences, because evening was the rush time for video streaming. In some cases, and under the load of this unexpected situation, operators lacked effective solutions to meet both the high bandwidth and the high quality requests. And moving a little bit the focus, we also think that COVID accelerated the already ongoing process of enterprise service digitalization. The demand for enterprises to offer their services into cloud has blown out. Enterprise services are required to be offered online and on demand, and the reliability of the entire network connection must be also ensured, which poses a challenge to operators' enterprise business. Then, summarizing, what we noted is that shared services or best effort contented services could not meet anymore this kind of pressure, and this weakness was clearly highlighted by COVID crisis, among many others. Obviously, the others that we are seeing during this very tough period are much more important weaknesses, not relevant to networks. But in this specific case, we can make a difference building or upgrading the network infrastructure to make it ready to underpin the digital transformation and to boost services to a higher level of quality.
Okay, thanks, Claudio. Ian, what are your thoughts on this?
Yeah, so, obviously a massive change and impact. So, what we did see was people adjusting to the at-home model, as we've noted, moving to work at home and school at home. And as Claudio noted, people even changed cities. In many cases, it was the people moved from, the city cores to just to where they live, to the suburbs. And so that all had a ripple effect, traffic, more traffic coming in through the fixed access networks, both the carrier side and then, in the North American market context, a lot more traffic on the cable networks. And then the traffic bump and ripple proceeded through there from the aggregation points. And then a lot was destined for the CDN sites. So we did hear some interesting cases and stories about pressure on particular CDN sites. And even the CDN sites got caught a little bit off guard and weren't quite ready for this huge burst in traffic. So a busy CDN site redirected traffic to a lightly used site. So you got some different kind of tromboning cases, as people did work to shift resources. So a number of the carriers that I heard from, really, a lot of them projected calm. And to be sure, this was, it's not even once in a generation. It's kind of a first ever that we've seen this kind of phenomena. But they pointed back to sound network planning fundamentals and, having a good refreshed network, and they did spend time monitoring to be sure. So, the network planning fundamentals, you never want to run the network completely hot and completely flat out. You always want some reserve capacity. Some of that reserve capacity was put into action to address some of the bandwidth burst needs. And then, there's a little bit of protection capacity that's above and beyond that was put into play, as a temporary measure. And then there's kind of the capacity pipeline where the carriers have put the orders onto their vendor partners, and capacity is it's on the way. And then we heard of ordering more. What carriers started to realize is, all of this is going to start to have a little bit of an impact on supply chains and whatnot. And, you won't be able to get the instantaneous just in time. So if you order, for needs that are out a number of months, then you've secured a supply. So yeah, just good, solid, fundamental network planning helped a number of carriers get through this unscathed. And then another thing that they mentioned was just having a brand new network. Some of the carriers were in an advantageous position that they just gone through a network refresh. So, if you've got a brand new network, you've obviously got a lot of capacity headroom to play with, and it's just a matter of adding in the extra endpoints. And then obviously they were monitoring attentively to be sure, and looking for the bandwidth hotspots and the bandwidth bottlenecks, and then getting out there and supplementing that. But yeah, we got a lot of positivity from the market, even though it was challenging.
Okay, great. Thanks, Ian. So let's go on to the next topic, which is the biggest changes from the pandemic. And going back to Claudio again, so from a networking perspective, what are the biggest changes you've seen from the pandemic?
Well, Huawei is highlighting since a lot that in the center of any technological improvement of the network infrastructure, there must be end-user experience. In fact, we spread the concept of networks moving from being traffic-driven to being experience-driven, which means, in the end, to meet the required service-level agreements for the end users, and also to differentiate them according to the different needs. There have been some social changes that will likely affect our habits, and the effects are not probably still visible, and we'll see them from now on. But what COVID showed is that with the right infrastructure, extensive smart working is possible, and also e-learning is possible. We have to recognize that this is something new, and that's a fact, and we have to take into account that before it was just a speculation, considering that it was applied in limited cases. So what also COVID crisis showed is that technology-driven investment can have a great return in resiliency of the entire society. Because technology has, and is still helping to respect the tough rules imposed by social distancing, by lockdowns, and in the future it can provide even more help to deal with whatever possible disrupting event, or on a positive side, to create new opportunities in a sort of creative destruction process. Behind that, we think that every subject involved in this crisis, which was so wide, enterprises, families, institutions, people, could appreciate the value of the services provided and what the different quality levels could achieve. So we think that they will be ready to pay more and to give more attention to premium network connections for a better quality experience. Or at least they will be asking for service parameters that fit better their needs and more attentive to that. And it is clear that it's a quite wide request, because if you think about governmental institutions, they will prioritize, as they did before, security and reliability. Financial institutions, ultra-low latency and reliability. Big enterprises, depending on the application, will focus more on security and high bandwidth, but they will also consider bandwidth on demand to face burst and the market variation. Then going on, retail services need reliability and more granular and flexible bandwidth. And for home broadband, as we highlighted as well, granted bandwidth is a must, thinking of e-learning, so we have totally to avoid situations with delays or interruption. So the right question is, can we grant these different levels for these KPIs? Can we monitor and control them, and possibly in real time? What is the time to market of these services, and does it fulfill the speed of a digitalized world for enterprises, institutions, and people? These are clearly open questions, and we think that optical technologies can have a great role in a positive outcome.
Thanks, Claudio. And now, Ian, what's your feeling on this?
A slightly different tack here on this one. So, the changes that we've seen from the pandemic. So, some of it is pretty fundamental stuff. We heard an awful lot about supply chain management and manufacturing capacity. So, we are into an event of, expect the unexpected. And, as different regions, unfortunately, move in and out of lockdowns, certain things may be up and then taken. So what we see and hear about in the early part is that the vendors that had the most chain fared the best. So, that's something to absolutely think about and plan for, being multi-sourced and able to source out of different geographic regions gives folks a greater strength. And they're sourcing, and then there's also, the actual manufacturing side as well. The same thing applies. If one site, unfortunately has to go down for a little while, if some of that production can be picked up by another site in another region, then you can keep moving forward. Another thing that we heard quite a bit about, through all this was the on-site work. And so, for much of telecommunications, we need to have people accessing sites. So they need to access cell towers. They need to get access to data centers. They need access into their own labs to test future technologies. And, again, with lockdowns and restrictions, some of this, the access was completely stopped for some period. And then what we heard is, folks did adjust quite quickly. Access was granted, but within the context of a new regime. So now, you need to think about some of the social distancing philosophies, and really it's kind of not a rocket science thing, but it's more of a planning type of issue, thinking things through and thinking ahead. So, environment of just showing up unannounced or showing up on a short notice, but, planning things out so resources can get in and out of sites, either to do the work or to do the lab work. So people basically need to be spread out more populations at some of these sites. So it just takes a bit more advanced planning, and that's what we heard. Exactly what people did and worked through. And then another area that was impacted a bit through all this was on the subsea side. So, we heard an awful lot about, the challenges and the tragedies with cruise ships. Well, the cable laying ships had similar challenges in that, being able to access ports for supplies, and then being able to access territorial waters and access ports to complete cable. So they had challenges there, and then you've got to manage crews, and you have to rotate your crews. You have to get your crews on and then off. You can't keep a crew on a ship in perpetuity. It creates a safety situation. So we heard a bit about that as well. So, some shocks to begin with, but then folks working through it and coming up with manageable plans going forward.
Okay, thanks, Ian. And next, I want to sort of start looking forward to the post-COVID era and look at optical technology development. So going back to Claudio now, so which optical technology developments do you believe will be most important for the post-COVID era?
So let me say again that COVID tragedy just accelerated some criticalities that were already there and reinforced some trends that the industry was already experiencing. So the picture we had before the COVID is described very well by Huawei Vision 2025, in which we expected a fully connected, intelligent world with 100 billion connected devices and around 30% of homes enjoying gigabit broadband, 5G users reaching 1.3 billion, and more than 50% of the network updated to support 5G. Then around 330 million or more users for virtual reality and augmented reality. It was also expected that all enterprises would adopt cloud services, and 85% of the services application of the enterprise's application would be deployed on the cloud, generating more than 180 zettabytes per year. And these are huge numbers. But what we now see is that this projection could be even higher for the simple reason that the subjects that were not yet connected will be pushed to be connected, not to be cut out from simple social life, but also realizing that connectivity, at least at the people level, is not just for fun, but it can represent really a factor of resiliency. And it will become more and more fundamental to work, to learn, to stay in contact. Then we see optical technologies and optical transport network as an enabler of all of this. So without transport, this cannot be realized fully. So optical transport is definitely evolving, and as far as optical networks are concerned, we highlight three main pillars of our strategic vision. Bandwidth increase over fiber is a traditional challenge, but it is clear that it's still very up to date, as the previous session fully highlighted. So we are coping with it in two parallel directions. One is increasing the single wavelength capacity from 100 gigabit to 200 gigabit, 400 gigabit, 600 gigabit, and the latest available line rate is 800 gigabit that we have already trialed. That is happening not anymore on single hardware, but for a single modulation of baud rate, but we are going to more and more toward a flex rate optical network, where the line rate will be adapted to the distances to cover and maybe will be changed on the fly according to protection switches and recovery path. Furthermore, we are definitely moving from a fixed grid to a flex grid network. This is another factor that maybe has not been fully highlighted. Flex grid is necessary to optimize the spectral occupation of the higher bit rates, and that is why we are also investing in order to enlarge the overall spectrum from the traditional 4 terahertz of the C-band to the 6 terahertz of the super C-band. That's Huawei name it. Implying that we have to upgrade the tunable lasers, PVS phase amplifiers, MUX-to-MUXes, and WSSs accordingly. This makes a very good moment for an infrastructure to be upgraded, to bring in flex grid, and also to extend the transmission spectrum. But in any case, we have also worked in order to fit, for example, the 200 gigabit line rates into 50 gigahertz, doubling the spectral efficiency in comparison to 100 gigahertz. At the same time, we improve the resiliency of the overall system to filter penalties in order to improve the connectivity on the optical side and reinforce the electrical switching in order to efficiently fill the huge wavelength pipes now available. We are talking about 800 gigabits, so near to 1 terabit. Second pillar involves the simplification of the network infrastructure and the architecture and of the platforms, granting the most advanced technologies in optical switching and OTN end-to-end connectivity from access to the core. ROADM architecture has played an important role into backbones and now are evolving not just to support more WDM directions, but also to implement the full set of features foreseen in the CDCG set. And this makes the platform and the network nodes very complex, with central offices burdened by fabric connectivity. I mean, the CDCG set fully implemented with traditional ROADM architecture. That is why we see platform with integrated optical backbone are fundamental in order to improve network possibilities and connectivity, simplifying the architecture at the same time. We also think that OTN will be widely used in central offices in order to further simplify the overall network architecture and grant a reliable, secure, transparent aggregation technology. Last but not least, we need to implement intelligent optical networks via SDN architecture, software tools, and embedded artificial intelligence chipsets and algorithms.
Okay, thanks, Claudio. And Ian, what are the optical technology developments you think are going to be most important during this post-COVID era? I think you need to unmute your mic, Ian. We can hear you now. No, we can't.
Sorry, you can or you can't?
We can now.
Okay. I was just going to say, I think Claudio really covered the waters there. I don't have any other silver bullet items, to add on top of what he noted. I mean, yeah, absolutely. A number of the trends that have been ongoing, need to continue. We need more automated networks with more advanced control. We've been going in that direction for a number of years. More probes in the network that are sending up telemetry information that we can take decisions before you get a catastrophic failure. You can get a little bit of a degradation and then take an action before you hit the catastrophic failure. And then a lot of the things that Claudio mentioned, they're all advanced technology items that ultimately get you to a lower cost per bit. So, absolutely, the industry continues to work on, the next generation coherent DSPs, which give the performance improvement, higher capacity, greater spectral efficiency, more system reach, which translates into a lower bit. And then that market is really split into, the very high performance, and then really what I like to think of as the space and power optimized. So focusing, maybe a little bit less on reach performance, but shrinking the footprint and shrinking power consumption, which might lead to some changes in architectures considered. And then Claudio's other point about the bands. I mean, we've been kind of a C-band world for years and years. And, every once in a while, band extension has gotten mentioned over the years. And I think we've got to a point where, the industry is really going to act on that now and take advantage of, bandwidth beyond the classic C-band. And I think where we'll see lead adoption and early adoption is folks that are working with a small number of fiber pairs. If you've got just a pair in this part of the network, then you're going to do whatever it takes to maximize the bandwidth out of that portion of the network for sure. And then you've kind of got to get the whole cycle going where you get the lead adopters, and then other folks jump in and kind of drive the supply chain and drive the volume, and then it makes sense for a broader, wider adoption. So I think we're at the front end of that trend too. So yeah, I think Claudio pretty well hit all the nails on the head there.
Okay, great. Right, well, I've got a couple more topics to talk about. So going back to you now, Claudio, in terms of what innovations and new practices will you be deploying in the next few years, and to what extent have these been accelerated or become necessary due to the pandemic?
Well, let me mention the attributes that we think are paramount for services from now on. Then that's a very important point. So guaranteed bandwidth with flexibility in bandwidth provisioning, availability, low latency, a shorter time to market for the services, security, and online possibility to verify what the required SLA service level agreements what are and if they are matched. So as network generation optical core highlighted already, there are different levels at which these attributes can be granted. And in the case of premium private lines, we refer to physical isolation for the bandwidth that can be provided and so-called hard slicing or piping that can be provided through OTN containers for wavelengths, for example, to more than 4 nines for the availability, meaning less than 52 minutes downtime, network downtime per year, less than 6 milliseconds per 1,000 kilometer connections, and the jitter contained within 10%, which means really to squeeze the latency to the fiber contribution, and then time to market of minutes instead of days or weeks, and the possibility to visualize quality indicators and make online changes without affecting the services. Now, with this in mind, it becomes very clear what we have to evolve, and in particular, network management system in order to integrate controllers and data analytics functionalities according to SDN architecture. But this is not sufficient enough. We also need to embed sensors and tools within our physical infrastructure to provide information and data, in our case, the iMaster Network Cloud Engine, to be elaborated via AI algorithms and to fully visualize the resources of the network and associate them to services and service level agreements. Again, this is not sufficient enough because in order to improve availability, we need to improve optical and electrical switching. And we think that the most advanced way in order to do that is to introduce optical cross-connect, an equipment with a real optical integrated backplane which can cope with more than 32 WDM directions in a full implementation of colorless, directionless, contentionless, and gridless architecture. So allowing one-hop connectivity within access and core thanks to the simplified architecture and the rationalized use of fiber connectivity. So not just all the use cases brought by the implementation of SDN architecture, but also the evolving architecture of the fiber transfer layer in order to add more flexibility and straight connectivity to the network at the same time, improving service KPIs when necessary. And let me do another example that fits the discussion. We are improving the fast restoration protocols with the target to improve the availability of the services at both electrical and optical layers, extending the domain of phase-on and WSON and integrating all the latest line rate and spectrum extension and flexibility. But if we don't improve the meshing of the networks in the core and ideally even in the regional and metropolitan area, these would have a less powerful impact, even if phase-on is 6 hours away. And that's a very important technology. So these things must evolve in association with the network architecture. Clearly, it is also down to fiber availability, but again, another quite important trend that we see is that fiber will play an even more important role in the future, being the most reliable transmission medium. Then improving the optical layer without improving the electrical layer is just solving part of the equation. That is why we are pushing optoelectrical integration on platforms like OSN 9800M equipment and supporting clustering to increase the equivalent switching capacity beyond 100 terabits. But OTN itself, which is a British technology, it is in all its applications to be improved in some aspects, like the granularity. Actual minimum granularity is obviously 0, so not very effective below gigabit rate. Huawei next generation proposal for OTN is called liquid OTN, and it will overcome the limits of the last actual OTN solution with improved granularity and influence bandwidth adjustment. It will reduce the latency introduced by OTN layering, reducing them from 5 to 2, and allowing milliseconds end-to-end latency in order to meet the new best quality service requirements. And obviously to be implemented from the access to the core, for any platform populating the network. Last point about technological development, is about cryptography and security then. So data are encrypted, and in order to encrypt them, we use a secure key, and we need to protect this secure key. Obviously, the point is that generating a secure key is a complex mathematical problem, and in the fact that the speed of solving these problems due to the computational capacity has increased, we need to increase the size of the key. So we push the quantum key distribution, so the quantum principle, in order not just to protect in a more safer way the key generation, but also to detect any attack in between, let's say, end users that are exchanging data.
Okay, thank you. Just before I'm going to go to Ian now. So in terms of new innovations and practices, what do you see service providers implementing over the next few years?
So I'll take this one in a little bit of a different direction and share a little bit on my personal experience from the at-home environment and what my household went through, with this change to at-home. So, for those of you that do know me, you may know that I've been a multi-year work at home. That's been the model. And so you do learn a lot by doing that. I mean, you learn quite a bit of the practicality. So what changed with the pandemic is my household added a number of other individuals into this local work at home environment. So we added one from the enterprise financial vertical, we added one from the research and education, and we even added one internet content provider. So a number of different industry types were now represented out of our household. And I get my from via a North American cable provider, the broadband service. So, kind of back to my point, the need to professionalize all this. I've had a little bit of a long-standing beef on when some companies like to do maintenance windows. And the old telco world, maintenance windows were a thing that was done but in some environment, it's viewed as okay to conduct maintenance during the middle of the day because they're not expecting to have 4 different enterprises operating out of one household and all utilizing collaterals and a lot of bandwidth. And it's not just the bandwidth provider; it's also our power utility would do standard maintenance during the day. And as the one that had been through this the longest, I was the one that was kind of quickest to react to when the bandwidth was unexpectedly taken down at 10 a.m. One morning. And I on a Teams call and so I kicked into kind of a rote response that I had. I tethered my computer to my cell phone and dialed back in. So I used the cellular network as my backup. So that was my backup. And in this particular case, because I'd done it before and I was a little bit used to it, I actually got back up in 2 minutes. So, I was down, I was out, I disappeared, but then I got back up in 2 minutes and rejoined the call that I was on. And then what happened with the other verticals in my house, the financial vertical and the R&E, one by one, they all came up into my little nook of the house and said, is the internet down? And what do we do? And I said, well, you've got a mobile, you can tether and you can, get back on that way. So, if we're going to do this long term, and this is going to be a reality longer term, and, I don't think we're all going to be 100% at home 100% of the time, but it's highly likely that more of us will be more at home for some percentage of the time. Then we really need to look at a more professionalized model here, which I've mentioned a little bit. And, that's about a real genuine secondary path for the at-home. And, I think there's some opportunities here for carriers, to be sure. And I think it would behoove the companies, so the enterprises, to pay for this upgrade. This is kind of going beyond, a home broadband entertainment. Now you're really working here, and you need this link up. So, the financial vertical and the R&E vertical and the, analyst consulting vertical, those folks need to, the companies need to, step up and pay for this and get us all to, real professional grade state so that we can continue to operate in this mode.
Okay, great. So we're going to go to our last topic now, which is optical networks at the edge. And going back now to Claudio, how do you see optical networks developing at the edge of the network to support 5G, fixed broadband, business services and utilities? And how has this changed due to the pandemic?
Well, here I don't see any major changes, if not the awareness that the network has to be upgraded from the access to the core to get relevant results. At the edge, we see the application of OTN CPEs, customer premises equipment, a new generation of CPEs that require just one visit to be installed and remotely configured. We call them plug-and-play CPEs, and these are ideal equipment for enterprise services. So just one visit delivered there and installed from remote, then operational maintenance fully controlled by iMaster Network Cloud NG. During the 4G deployment, we already implemented centralized RAN architecture showing that BBU centralization can reduce both CapEx and OpEx. Now with 5G technologies, these will be more extensively used, and we have considered all kinds of solutions, from passive ones to active ones. And what we are now proposing is the semi-active solution, which uses passive mixed muxes and WDM SFPs in the AIU RRU side, whereas the active part is just in the BBU side. This is an easy deployable solution that can support remote fault location. Last but not least, for the same reasons brought here of granting reliable best quality service in a simplified network infrastructure, we think that the industry should rethink the position of optical networks at central office. OTN to central office become more and more important to improve the quality of end-to-end connections, including low latency, less bandwidth, and high reliability. As an equipment provider, Huawei will strengthen technological innovation and launch new products to match the trend of OTN penetrating the central offices.
Okay, great. And finally, Ian.
Yeah, maybe just kind of some concluding comments, on how the edge of the network will develop. I mean, did mention this earlier in the talk, but absolutely seeing more and more momentum for the edge, and it's going to be tempered. I mean, it's really about matching the business models and the applications and that revenue stream to the cost outlay. So what we've seen sort of early days is the repurposing. So the repurposing it's a pretty economic choice. I mean, folks already have the land, the building, and it's more of an incremental upgrade. Another thing that I didn't mention earlier is, we're starting to see, new entrants offering edge compute solutions, really designed for being located at the tower location. So these are, container-sized edge compute, and again, it's really keeping that initial cost low, but matching the revenue to the cost profile, so people don't get ahead of themselves in expense and searching for the revenue. And yeah, it's going to, we do hear a lot about the fund economics, but one of the things that I've liked, and I mentioned before, and just kind of re-emphasize, is the life cycle costs. And we've seen this in different enterprises over the years. I mean, who has some server that hasn't been touched in years and years, and it's running an application that we believe is needed, but the individual that really knew it has since retired. I mean, we've all heard these kind of nightmare sort of situations. So what the edge and the whole cloud model enables you to do is manage that and constantly stay at the front of the technology curve and not let things get older and age out. So yeah, we expect it to continue, but measured and a long arc. People are going to manage their capital judiciously, but will spend when they can see the business model and the application revenue side.
Okay. Nice. Yeah. Okay. So thanks, Ian. And with that, we're going to go on. We were going to go on to our Q&A session. Unfortunately, we are running a little over, so I'm just going to go to one question for each of our speakers, and then we'll have to bring the session to an end. So going to you, Ian, first. So the question is, when moving moving the cloud computing to the edge or closer to the customer premise, what is the impact on the network, on the optical network, and in particular, does it reduce traffic to the centralized data center?
Yeah, so the way that I would think about that is, this is absolutely a growing pie. So it's not that, one is going to become significantly larger and the other will shrink. It's that they're both going to grow, and they're both going to grow at different rates. So one of the goals of edge compute is definitely to, I just want to choose my verb here carefully. You want to send less traffic to the cloud, but it's not going to, it's not going to shrink. It's just going to grow at a slightly lesser rate than if you had absolutely no edge compute. But it's absolutely going to grow. And then we expect, a ton of growth on the fan-in side and the metro side. So yeah, the message that I want to leave there is both growing. Tons and tons of growth on the metro access side, and then growth into the core as well.
Okay, great. And just before we go to the last question, I'm just going to push a survey onto your screen. If you can fill out that before you go, and just listen to Claudio on the last of our questions. Now, Claudio, this last question is, so what are the main use cases supported by the implementation of your SDN architecture?
Yeah, sure. Referring to what I just said, definitely SLA visualization, resource virtualization and visualization, latency not. So we are giving more and more importance to latency. We have already implemented application where latency is fundamental, and not just referring to financial institutions. So we need to measure the latency, and that's what we do, not to assume the latency, but definitely to measure the latency over the network and provide to the operators a visualization for the latency, and then the possibility to differentiate the path selection according to the latency. So different policies in order to do that. Then let me mention the fact that definitely super important is the use case of proactive operation and maintenance. Providing a sub-helping condition for the physical network in order to identify failures in advance and allow to strongly reduce OPEX and avoid completely any failure over the network. So this is, I think, the most important use case that we are addressing. And again, also the visualization of the CPs, the plug and play, and the remote management of that.
Okay, great. Well, I'm afraid we have run out of time today, but thank you very much for joining us, and thank you to our speakers, Claudio Lugari from Huawei and Ian Redpath from Omdia. And this session was brought to you by Light Reading and NGON&DCI World. Thank you very much, and have a good day.
Thank you. Have a good day, too.
Thank you, Simon.